Our topic is graphing quadratics without the use of a calculator. There are three forms for writing quadratics, and the first of these is what we call the intercept form. What we need to do to draw a graph of a quadratic is identify enough key points so that we can determine the shape and exactly where it crosses the axes. Here's our example. Now the first thing we want to do is identify the line of symmetry. This is very easy to find when the quadratic is in intercept form because it is simply the opposite of whatever this number here is. In other words, the opposite of b. So the line of symmetry is simply x equals -1. We are not talking about a point, we are in fact talking about the equation of a line. Now once you've found the line of symmetry, we know that the turning point will always be on that line. So to find the turning point, you let x equal -1 and then calculate y. X equals -1, -1 plus 1 is 0, 0 squared is 0, minus 4 gives y equals -4. We can also say that this is a minimum turning point, and the rule is when a is greater than 0, you have a minimum turning point. This applies to all three forms, and therefore we can also say that the parabola will be concave up. Now to find the x-intercepts, that means y must be equal to 0. What we're doing now is looking at this part of the equation. The number inside the bracket must equal 2, so that 2 squared equals 4, 4 minus 4 equals 0. So by inspection we're looking to find what values of x will make the inside of the bracket equal 2, because 2 squared equals 4. You can see there that x equals 1 gives y equals 0. 1 plus 1 is 2, 2 squared is 4, 4 minus 4 is 0. The other value of x is -3. Remember that for quadratics you can have a maximum of 2 x-intercepts. To find the y-intercept, we're going to let x equal 0. So putting x equals 0 into the equation, 0 plus 1 is 1, 1 squared is 1, 1 minus 4 gives -3. Okay, so we've got enough information now to plot the graph. The line of symmetry is x equals -1. The turning point on that line is -4. Our x-intercepts are -3 and 1. The y-intercept is -3, and now we can sketch the graph. All of this can be done without a calculator, but if you want to check the accuracy of what you're doing, then of course you can use your class pad in practice, and if you're in the calculator assumed section of the exam, you can use your calculator then to check. The second form is factor form. Here's our example, and you can see that the quadratic is written as a product of two factors. It's easiest to find the y-intercept first, which is when x equals 0. So substitute x equals 0 and you can calculate y equals 21. The x-intercepts is when y equals 0, and in factor form this is very easy. What you're doing is looking at each of the brackets in turn and solving, in this case, x minus 3 equals 0. So that gives 3, 0, and the second bracket must also be equal to 0 to find the second intercept. So x minus 7 equals 0 gives x equals 7. In factor form, once you've found the x-intercepts, you can then find the line of symmetry, which is exactly halfway between the two intercepts. That's because a parabola is perfectly symmetric. So it's easiest if we plot those intercepts now, and the line of symmetry has to be exactly halfway between. We're looking at the distance between 3 and 7, so you can simply do 7 minus 3 equals 4, halve that, 4 divided by 2 equals 2, and then add 2 onto the 3 to get 5. That's a general approach that will work. So we can plot that, and the equation of that line is x equals 5. Always find the turning point immediately after finding the line of symmetry, which is very easy because you just substitute x equals 5 and you can work out that y equals -4. This is a minimum turning point because once again a is greater than 0, which means that the parabola is concave up. So we can now plot the extra points we found. The turning point is -4, the y-intercept is 0, 21, and you can sketch the graph. Once again, here's the graph plotted with the aid of a computer or calculator. The third form is standard form, and here's our example. The first thing I notice is that a is negative. When a is less than 0, the graph will be concave down. Alright, so to find the line of symmetry, we have to use this rule. The line of symmetry is x equals -b over 2a. So substitute the values into that rule. I always recommend that you put the number in a bracket to make sure you don't mix up positive and negative signs. b is 4, a is -2. So -4 divided by 2 times -2, which is -4, gives 1. So the line of symmetry is x equals 1. Always find the turning point straight after that by substituting x equals 1 in this case, and y can be worked out to equal 3. This is a maximum turning point, as I said before, because a is less than 0. The y-intercept is when x equals 0. Substitute x equals 0 into the equation and you get y equals 1. Now in this example, we're not asked to find the x-intercepts or the roots of the equation. This is actually the least user-friendly form if you're graphing without the aid of a calculator, because the roots will often be difficult to find. If you can factorize standard form and put it in factor form easily, then you should, in order to find the x-intercepts. But in this case, they are certainly not whole numbers. But we do have enough information to sketch our graph. So I'm starting with the line of symmetry. The turning point is 1, 3, and the y-intercept is 0, 1. And that's enough information to approximate the shape of the graph. If you are working with a calculator and you want to check this, you can use gsolve to get the roots, which I've given to 3 decimal places. And once again, here's the actual graph plotted. Remember that a quadratic is symmetrical about a line of symmetry. You can have a maximum of 2 x-intercepts or roots. And as always, if you're going to plot a graph accurately, you need a few key points to determine the shape and exactly where it crosses the x and or y axes. It doesn't really matter exactly what order you work things out in, except I always recommend that you find the line of symmetry and then the turning point immediately after that. Alright, so that about wraps it up. Hope you found that helpful.